So to start, we probably all agree that trust is very important in that it precedes and promotes economic prosperity. Now, throughout human history, we have actually created a spectrum of trust mechanisms where, on the one end of the spectrum, we have the more laissez-faire approach, such as reputation system. And the idea there is that some market regulators will aggregate information about, sellers' past performance, and then simply display these summary statistics to buyers and let buyer make their own purchasing decision. Now, on the other end of the spectrum, we have the more, boots on the ground policing type of approach where, the market regulator is going to find the erroneous sellers, extract payments from them, or even put them into prison. Right? So that's the more policing regulatory type of approach. Now, of course, these are just two examples, and there are many mechanisms, trust mechanisms, in the middle, like different, nudges, like information nudges, or playing with the search ranking algorithm to nudge consumers to interact with more reputable sellers. Okay, so we really have a very wide variety of these trust mechanisms, and if you look at all of them, a common theme is that all of these mechanisms on the spectrum would always involve a trusted third-party intermediary, right? So think about in the reputation case, you have either the platform like Amazon saying that this is a 5-star seller, or you have somebody like Moody's who's saying that this is A+ bond or stock, and so forth. And with the regulatory approach, of course, you have the governments or you have the courts. So there's always an intermediary. Now there are a few problems when you have these intermediaries. The obvious ones is market power and the existence of a intermediary rent. But for what we're going to be focusing on today, we're going to be thinking about this other major problem of having intermediary, which is the existence of this transaction cost associated with using these intermediaries. And by transaction cost, there are really different types of transaction costs, like the cost of acquiring information or learning about the rules of these intermediaries. There's the communication and bargaining cost with these intermediaries, and the litigation or enforcing contract cost. So we know from a large literature dating back to the 60s by Coase that the existence of these transaction costs can reduce economic activity or even innovation, right? So as as Luis was saying, a lot of my research has been focusing on sort of thinking about how do we optimally design different information mechanisms or trust mechanisms, from an empirical point of view, and that's background, got me sort of really interested in this blockchain stuff. It is, the feature of the blockchain that got me super interested is the fact that we can actually, or the technology has the potential to achieve scalable trust without this third-party intermediary, right? So that's what really got me interested in thinking about the problems in the blockchain space, right? So in particular, it's not because of cryptocurrency, Bitcoin or FTX. So I never consider myself as a finance guy. I do own some stocks, and I did short the market during the pandemic, and of course I lost some money, but that's pretty much it. Okay, so I got interested in this stuff, because I'm interested in thinking about trust. Now, throughout this talk, I will be sort of focusing on the economics of these technologies rather than sort of the technology itself. So that means that I will give you the bare minimum so that you understand what the technology do, without sort of throwing a lot of jargons at you, okay? So first, smart contracts. So what are smart contracts? Well, these are essentially programs of if-then statements on the blockchains, okay? And blockchain are nothing more than distributed ledgers with good properties. Okay. Now, the way that these smart contracts work is that they are going to interconnect with external data feeds. And they do this so that they can constantly check the if condition, check whether the if conditions are satisfied, right? So the data feeds keep the smart contracts aware of the current state of the world. Now, the smart contracts are going to automatically execute the then statement, right? The contract once some pre-agreed conditions have been met. Okay? So that's in a nutshell what smart contracts do. Well, you can already see from this description that, since, the contract execution is done programmatically, there isn't a need for intermediary, at least in principle, when we use smart contracts, right? Now, given the pervasive use of both, explicit contracts and implicit contracts in the economy, there's reason to believe that a wide adoption of this technology could have large effect on economic efficiency and innovation. And in fact, we already are seeing, a large number of innovations in this space, such as various decentralized autonomous organizations, right? The DAOs, different innovations in decentralized finance, and non-fungible tokens, which are used in currently mainly in gaming. But in the future, it could also be used in other things like decentralized governance and so forth. Now, besides or putting aside the good stuff, there's also a problem with the technology. And the problem comes from the fact that smart contracts sit on top of the so-called base layer blockchain technology. Okay. Now, because of these residents, smart contracts also inherit problems with blockchain, which is also known as the blockchain trilemma. And what the trilemma is saying is that, you cannot achieve scalability, decentralization, and security of the system at the same time. So what do these terms mean? Well, scalability basically means how costly it is to use the system. Decentralization refers to where the control of the system lies, right? Is it sort of lied within a few people, like the platform owner, or it's more sort of in the hands of the people, right? And lastly, security just means like security or safety of the system. Now, all of these three components are important, and they can be more important than others depending on your specific use case. But increasingly, scalability is regarded as being the bottleneck for adopting smart contracts. And there are a couple of reasons for that. The first one is the obvious cost reason, which is that, essentially, if sort of adopting this technology is more costly than the transaction cost that it's trying to save, then it just doesn't make sense to make the switch, right? It doesn't make sense to adopt a new technology. And the second reason, which is perhaps less talked about, is the fact that it's very likely empirically that scalability and decentralizations are highly correlated, in that the lack of scalability would typically imply concentration. And the logic is that if it's very costly to use a system, then only a few people, say a few sellers, will be able to afford it, and essentially that entry barrier is going to create market concentration. So there's also the decentralization reason for why scalability is sort of it's a major bottleneck. Now, firms and startups, in this space have been actively experimenting the so-called Layer-2 technologies for scaling. Examples include state channels or off-chain methods. So I wouldn't go into details what exactly those things are, but essentially the idea is to take some of the processes or computation burden from the blockchain to off the blockchain, right? Hence the word Layer-2 solution, right? So blockchain is the base layer technology, and then we're sort of taking something off it to the second layer. Now, despite all of these experimentation efforts, there has been little empirical evidence on whether these things work or not, and also the economic implications of increased scalability. Now, this is where our paper comes in, where we study the effect of an off-chain solution for scaling smart contracts. Now, the empirical setting in our paper is Chainlink. So again, avoiding all the technical jargon, Chainlink is essentially a platform that provides data feed to smart contracts. Okay, so what is the data feed? Well, an example of that could be, the exchange rate between Ether and US dollars, at this moment of time. Okay, so that's a data feed. Now, the way that the Chainlink system operates is that for each data feeds, there's going to be a network of service providers who are going to vote. So they're going to vote on what they think the exchange rate is. Okay. Now, once these votings are done, these votes are going to be aggregated into a single data feed based on some predetermined algorithm. Okay, so in this case, it's mostly taking the median of all the votes. And once we have this aggregated data feed, that's going to be updated on the blockchain. Okay, so that's essentially the workflow of the Chainlink system.
Xiang,
now,
there's
yes,
just one question by Hannes. Hannes, you want to ask it, or?
Yeah, so I hope I'm not too late for this. It was a bit more on the first slide. So I was wondering, because you mentioned the transaction cost of induced by the intermediary, having to trust the intermediary. So isn't it also an issue that, people have to trust the technology, in particular when you said in the next slide that firms are experimenting with different technologies. So is the assumption right now that the trust will be established and unquestioned, or is it different?
It's the difference is about trusting people versus trusting codes, right? Now, of course, there could be barrier in terms of understanding how the technology works, right? Like whether codes do what they're supposed to do, but that's sort of a different layer. But yeah, you're exactly right. Now we're shifting trust for people to trust for codes.
Okay.
Right. Okay. So a key to our paper is this policy change in 2021, and essentially this policy change is going to create a transition period where we have two parallel systems running. Okay. In particular, we have the original system where the voting, the individual votes, and the aggregation are going to take place on the blockchain. Whereas in the new system, we're using an off-chain scaling solution, right? So we are going to do the voting, the individual voting and aggregation off the blockchain in a peer-to-peer network. Okay, so that's where the difference comes from. And once we have the aggregated output, Chainlink is going to update them on the blockchain. So the updating part is always on the blockchain. Now, in order to understand why this matters, it's important to note that almost 99.9% of the cost of using the system comes from interaction with the blockchain. Okay, so for those of you who know the price of Bitcoin and Ether, you know that it's like very costly to play with these chains, right? So that's where the cost comes from. And you can see that in the original system, just in terms of cost, the number of interaction of service providers with the blockchain is going to be the same as the number of individual votes, right? Because all the individual votes take place on-chain plus one, right? Which is the final on-chain updates. Whereas in the new system, we only sort of incur one times the cost of on-chain update. So that's sort of where the cost reduction comes at. Now, we think that this creates an ideal setting for studying the scaling solution for smart contracts for a couple of reasons. So the first one is that we have a rare exogenous variation in the operating cost of using these smart contracts. And I will talk, in a few slides, why having this parallel system is almost ideal for causal identification. And the second reason,
Oh,
Yes.
sorry. There's
No worries.
another clarification question in the
Yes.
chat. I don't know if Aija, do you want to unmute yourself or?
I can. Oh, I'm on camera. Yeah, I just wanted to ask if you're just making an assumption that blockchain is proof of work systems, because everything that you spoke about sort of seems to assume that, but there's a whole other world out there with other
cost issues.
other consensus mechanisms.
Yes, so proof of work is notoriously known for its larger cost. So this off-chain solution is going to be helping proof of work, especially more. And actually, during 2021, if Ethereum was proof of work, so it was definitely more relevant. But I would say that the idea of off-chain solution also works when you have a proof of stake consensus mechanism, because again, this is not about how the base layer consensus is achieved. It's about the fact that we're giving the cost of using the base layer technology, right? Using the base layer infrastructure, we are taking some of the computation and some of the burden, the aggregation process or whatever, from on the blockchain to off the blockchain. And to the extent that doing this off-chain is more costly, it's more cost saving compared to doing this on-chain, then we would have a reduced cost of using the system and hence more scalability. So, it's in some sense not relevant, what the base layer technology, the consensus mechanism of the base layer technology is.
There was another question by Nancy. I don't know if you want to unmute yourself.
Yeah, right. So I just want to quickly ask, but wouldn't this voting and aggregation stage be centralized exactly because of the same reason that you gave on the last page, I think? So first of all, it then requires trust, trusting agents, right? Or the few service providers. And then secondly, it's not scalable. So it would be centralized or concentrated, right? Which is contrary to what blockchain tries to.
Sorry, so just to clarify, so that I understand your question, are you referring to the original system or the new system or both?
The voting and aggregation
right.
part in the new system.
Right, so the voting part is based on code, right? So even though it's taking place off-chain in the peer-to-peer network, it's based on a code. So I mean, I will tell you the exact process in a bit, but it's not that, so there's no room for maneuver. Now, of course, that's being said, arguments can be made that data is most secure when it's on-chain, right? So, if you do stuff not on the blockchain, but in a peer-to-peer network, then, even though peer-to-peer network has a lot of desirable properties, but there are also like known technological disadvantage of these P2P networks, right? So it's still subject to the P2P network. So that part is correct. Yes. Then the question is that, hey, and by the way, in the paper, we did not find that, the data accuracy was worse after using P2P network. But that just means that we haven't observed it empirically, right? So it could be that there could be some like disaster in the future, which, we just never observed in the past history. So that's certainly possible. But then the question is, how much are you willing to pay, in order to use this on-chain method versus this P2P method where, we know there could be some risk, but, it's not really there in the data, right? And, I'm going to show you what our estimates on the cost saving is when we do things off-chain, when we do the data aggregation off-chain. And, if you're sort of, you have a preference about, P2P versus on-chain, then you should sort of keep that cost saving also in mind in order to make the optimal decision.
Okay, thank you.
Yeah, no problem. So Luis, or Hannes, do I have more questions? Yeah, I after so many years of Zoom teaching, I still have just one screen.
There's no more questions for now.
Okay. Right. So the second reason that we think that the setting is good is because this off-chain solution that we're looking at is actually quite general. Like it's the idea of taking some of the computation burden from on the blockchain, from where it's costly to do to a place where it's not so costly to do, and that applies to other distributed networks where the final output is decentralized and based on peer-provided information. Okay. So let me give you a preview of results. So first, as the policy was intended to do, we have a very large reduction in the operation cost of using the system, which is about 76%. And if you sort of use the volume that or the amount of total cost that Chainlink has paid in the first half of 2022, then that is going to be translated into $260 million of annual cost saving reduction. Right? So it is definitely a very sizable reduction for the Chainlink system. Now, second result, in terms of data integrity, it was actually to our surprise that the accuracy of data feeds actually slightly increased a little bit. And when we sort of dig deeper into these results, we find that this slight increase is actually driven by the third result, the decentralization, and in particular, is driven by the fact that because we have a very large reduction in the system cost, Chainlink is going to be able to afford more service providers to work on each round of the job. So we have a dramatic increase in the number of service providers that participate in this decentralized voting process, and therefore it's sort of not surprising that when you have more people vote, the final votes become more accurate. Okay, and in a bit I'm going to show you that the fact that data feeds become more accurate is entirely explained by the fact that we have more participation due to this decentralization. And not only we see more participation, but also at the market level, we see a reduced concentration among these service providers. Okay? And lastly, we have some early evidence for scaling, which is that essentially demand measured as the total number of smart contract calls increases after the policy change. Okay, so we think that our contribution of the paper is that we provide some early evidence that an off-chain scaling solution leads to cost reduction and decentralization, and data integrity is not compromised. So this suggests that as the technologies improve, so that scalability becomes better over time, the original promise of blockchain, of decentralized, scalable trust can be achieved. Okay, so in order for what I'm saying make more sense, let me spend a few minutes talking about what exactly the data aggregation process was. As I think that was also related to the question that Nancy was giving. So basically, during the period where we have two parallel systems for data feeds, in the original system, the workflow goes like this. So first, for each data feed, Chainlink is going to select a committee of data service providers. Okay. Now, a new round is going to start when these providers think that the data feed is outdated, and being outdated meaning that either the new aggregated data feed is sufficiently deviating from the current data feed, or a certain amount of time has passed. Okay. So when the data feed is outdated, these providers are going to submit their votes to the blockchain. Okay, and they get paid for doing that. Now, Chainlink's smart contract is going to aggregate all these votes by taking the median of it and then update it on the blockchain. Okay, so the key thing to note is that in the original system, all of the individual votes were happening on the blockchain, right? Now, in the new system, the first step is exactly the same. For each feed, Chainlink selects a committee of providers, and the service providers constantly submit their data and signature to a off-chain peer-to-peer network. Okay, so this is where the difference comes compared to the original system, in that now the individual votes are submitted in the P2P off-chain network. And the reason that they can constantly do this is because it's basically zero cost of submitting data off-chain. Okay? And now when the data feeds becomes outdated, with the same criteria, then the service provider will be randomly chosen to help with the on-chain updating process. Okay, now what does the leader do? Well, the leader is going to assemble a final report with not only just the final aggregated data feed, but also all the individual votes with the individual signatures, right? So on the blockchain, there's going to be record of who voted on what, and the signature makes sure that it's uniquely identifying the person who said these things. Now, lastly, the leader is going to update this entire final report on the blockchain. Okay? So you see that the policy change reduces the number of interactions with the blockchain, and that, of course, implies a small operating cost. But what is sort of an open-ended question is, how has data integrity been affected by this policy, right? It depends on the performance of on-chain aggregation or on-chain voting versus the off-chain peer-to-peer network voting. As I was saying, there's reasons to believe that on-chain is the safest. So anything that's not on-chain is sort of worse off. But then on the other hand, we also need to realize that, we have certain mechanisms in the P2P network that sort of tries to counter this force. So for example, even in the P2P network, we have 16, service providers on average, which means that we still have a decentralized voting. So it's not like, you can corrupt just, a couple of nodes or a couple of service providers, and because it's going to be washed away by taking the median. Another thing is staking, right? So staking means that all of these service providers, they have to deposit some money into the Chainlink systems before they become providers. And if Chainlink finds that their reports is like way off, then their staking will get slashed. So they will not get their staked money back, right? So that's another sort of static incentive for them to be honest. And lastly, remember in steps 3, I said that all of these individual votes will be recorded on the blockchain, right? So that means that future employers, they could theoretically go back and see that, hey, some people said something that's really off before. So there is some dynamic incentive there, right? Some reputational concerns for individual nodes or service providers to behave well. So it's sort of not that clear how data integrity is going to be affected. Okay. So now let me talk about the identification of the paper, which I think is quite neat. And the neat feature comes from the fact that Chainlink didn't just switch from an old system to a new system. So in fact, what Chainlink did was that there was a transition period where Chainlink ran 2 parallel systems for the same data feed at the same time. And we have the control system, which is the original system with on-chain aggregation. And then parallelly, we also have the new system with the off-chain aggregation. Okay? And the reason for Chainlink to run 2 parallel systems is to essentially hedge risk, right? So Chainlink is actually by far the dominant leader, in this space that provide data feeds to smart contracts. So in fact, they are I think 16 times larger than the second startup in this space. So they're really large. So they have a lot to lose, right? So their idea of running sort of the original system as a backup was that, if some unforeseeable event happened in the treatment method, right, in the treatment system, then they would be able to instantaneously switch back to the old control method and have, data feed from the control method submitted to the blockchain to, for the smart contracts to use. Okay, so that's the rationale behind these parallel systems. Now, in terms of identification, that's great for us because that means that we actually observe the same unit being both in the treatment and control group at the same time. So in some sense, this directly addresses the missing data problem, which is the fundamental problem in causal inference in Rubin's causation framework. So because of this feature, the analysis is quite simple. So it's basically a cross-sectional comparison, which compares the outcomes from the 2 systems in this transition period, while controlling for granular fixed effects, which is blockchain by data feed by date fixed effects. And the fixed effects are there to control for unobserved heterogeneities, both cross-sectionally, like the fees are different for using different blockchains. And there could be different systematic accuracy in different data feeds and so forth. And also these fixed effects can control for variation at the time dimension, such as fluctuations in fees from changes in token price over time. So we did some additional steps in terms of identification. So first, we did some basically balance check, right? Baseline balance check, which is that we checked that the past performance of service providers that are assigned into the treatment and control systems for the same data feeds are similar. Okay, and this sort of makes sense because Chainlink was not trying to assign better providers to treatment group because if it fails, then Chainlink sort of wants to be able to save itself, right? So it really cares about the quality of the output very similarly across treatment and control method during this transition period. So it was not the case that treatment providers are better. It was also not the case that Chainlink allocated more money paid to service providers in the treatment system. And lastly, one note about our treatment, which is the parallel system treatment, is that it started for different blockchain by data feed pairs in a staggered fashion. Right? So in particular, it was the case that blockchain data feed pairs that were more costly to begin with, saw this switch first, right? And it also sort of makes sense when you have this get staggered entry. But this scattered selectivity in sort of entry is actually not a problem for us because unlike many other papers using staggered entry, we're not using like time series variable. We're not comparing the system performance before and after the entry, right? So we're sort of fixing the time and comparing across the two parallel systems. Right? So, in other words, if you want a more technical explanation, the level of fixed effects that we're able to control for, which is blockchain by data feed by date fixed effects, is more granular than the rules that determines the timing of treatment, which is blockchain by data feed. Right? So therefore, this is actually less troubling for us. Now, of course, it creates some problem in terms of, how do you optimally, to think about what's the policy relevant parameter, right? Because depending on when a unit is treated, you would give different weights to units that are treated earlier. So that's why, in the robustness check, which is in the appendix, we play around with, assigning different weights to different units, but that doesn't make any difference. Okay? So that's in a paper.
Xiang, we have another just clarifying question
Yes.
from Nancy. Yeah, you want to go ahead? Go ahead.
Yeah, just very short. So you're saying that I understood that the old system, the median was chosen, but then for the new system, you wrote on your slide that it's a randomly chosen submission, but then you orally said it's also the median. Right.
So sorry. Random in the sense that we have on average 16 providers in the P2P network. And we randomly choose one out of the 16 people to be the leader who will be helping with the on-chain updating process. So that's where the random, that's what I mean by random, but it's still taking the median of all the votes. Okay, right. Okay, a very short follow-up, you can answer that later as well. I don't know if you're familiar with the median voter theory in the public choice. So basically it's saying that, with such, especially when the transaction is not simultaneous, then there is a room for rent seeking or, for some improper influence in the decision-making process. And I wonder if, this can maybe affect the new system. Yeah, definitely. I mean, I think, and this is, I think, where the cool part of this thinking about the blockchain system is that there's a lot of room for market design and mechanism design questions. And there's obviously many problems associated with taking the median votes, like the one you said. And I agree that flaw also apply to the current system. But the point, I guess, we're trying to make here is that, when the system cost is sort of reduced, then you would be able to have more people sort of coming in and vote. And presumably, with more people voting, then the problem sort of goes away compared to if you just have two people vote. And the outcome would be like, in some sense, more problematic compared to when you have more people, if that makes sense. Right. Thank you.
Can I ask a quick follow-up too?
Yeah, of course.
So in practice, while those two systems were used, the vote outcomes for the original system were used for everyone, and the treatment was just the backup. Is that?
That's right. Yeah.
Okay.
Yeah, that's pretty much. So what it is that I think if you look at the data, most of the demand or fulfilled demand, meaning like requesting smart contracts, right? The smart contract says that, I want to know the exchange rate. So most of them are sort of resolved by the new system. But that said, the old system is still sort of running. And if you think about our analysis, really demand side doesn't play any role, right? It's really about the supply side because, that's how the system is designed currently.
Okay.
Yeah.
Thanks.
Yeah, no problem. Right, I talked about this. So where did our data come from? Well, we scrape data from the Chainlink website, Web3 API, Etherscan, and BSC scan, and Binance exchange. So the data is at the level of blockchain by data feed, by date, by treatment group level. And, for each observation, we observe the average operating fee per round. We observe data accuracy, and this data accuracy is constructed by benchmarking the decentralized Chainlink consensus, right? What Chainlink thinks that the current exchange rate is, and we benchmark that with respect to the value for that exchange rate from Binance, and Binance is the largest centralized sort of cryptocurrency exchange. Okay, so we're not saying that Binance data is good, but we need a benchmark to compare the Chainlink consensus, right? Before or in different systems. So the assumption here is really that Binance data sort of the quality of Binance data is sort of similar within the day. We also have the number of participating service providers per round. Okay, so that's the type of data we have. Sample period is between May to September 2021, and the reason for this is that if you look at the graph that plots the share of treated observations over time for the Ethereum blockchain and the Binance blockchain, which are the two largest blockchain that Chainlink has service on. The overlapping period is sort of from May to September, right? So we are essentially using the overlapping period for our estimation. In terms of summary statistics, the average operating fee per round in the control system, in the on-chain voting system, is about $100, whereas that for the off-chain method is only $30. So you can already see from the summary statistics that there's a big decrease, subject to the caveats of dynamic selections and different confounders, which we deal with the fixed effects. Now, if you look at the deviation from the Binance benchmark, that's about 0.3% in both systems, and number of nodes per round increases in the off-chain method. Okay. All right, so first result, which is about cost of using the system. So this graph pretty much says it all, right? So on the y-axis, we have the average fee per round, and we plot that against date for the control system in the solid line and the treatment system in sort of the dashed line. And the left graph is for the Ethereum blockchain, and the right graph is for the Binance blockchain. So you see that for both graphs, it's pretty obvious that the treatment cost or the cost in the treatment method is much lower than that in the control method. Now, of course, to properly identify this, we need to control for fixed effect. The regression is a simple cross-sectional regression. So YBDTG is outcome variable for blockchain B, data feed D, time T, and group G. And we regress that on an indicator for treatment and controlling for this psi fixed effects, which is blockchain by data feed by date fixed effects. Standard error clustered at the blockchain by data feed level, and we also visualize the outcome, at the 1% level. The top, we remove top one, or we cap the top 1% and bottom 1% to remove the effect of basically outliers on the outcome, and outliers coming from extreme volatility in these token prices. So if we run that regression with fees, and by the way, the two columns corresponds to how we cluster standard error. So the first one is the heteroscedasticity robust standard error, and the second column is cluster standard error. So we see that the average fee per round decreases by about $82, and given the control average, that translates into a 76% decrease. And we can sort of compute that annualized cost saving based on Chainlink's volume, and that's equivalent to $260 million, okay, annualized, which is a very large cost. So that's not very surprising. I mean, that's what the policy was intended to do. What's perhaps a bit surprising is that when we look at data integrity with this deviation measure, and by the way, the deviation measure is defined as the log of the Chainlink consensus over the Binance data, right? So think about this as percentage deviation of the Chainlink consensus with respect to Binance. And we see that, if we do not cluster standard error, we see that there's a reduction in deviation, means that the system is getting better. And if you benchmark that with the average, then we have a 6.3% smaller deviation. Now, in the second column, if you do cluster standard error properly, then you sort of lose statistical significance. So it's only significant at the 10% level. Now, this result, is sort of a bit surprising. And as I was talking about, this actually comes from the increased participation. So I'll get to that in a slide. But first, if we look at the number of participating nodes, then we see that there's an increase, in the treatment system compared to the control system, and that's about 79% increase, right? So essentially what happened was that, Chainlink can afford to pay more service providers for each round of the job, given there's a smaller operating cost. And then what's the downstream implication of that? Well, if we go back to the deviation regression and now include the interaction between the treatment dummy and the number of participating providers in that round, then you see that, first of all, if we do cluster standard error, nothing is significant. So I'm just going to be focusing on the heteroscedasticity robust standard error. So if we trust these results, then this is saying that the better data integrity is entirely driven by more participating providers. In particular, in the old system, where on average we have 9 providers, then if we do 9 times the interaction effect, plus the standalone treatment effect, then it's basically 0, right? So it's saying that just switching from the old system to the new system doesn't change data accuracy at all. It doesn't change the accuracy of your data output at all. It is only when you have more and more providers that brings down the deviation. Okay? So it's really saying that, in a nutshell, that when we have a scalability in the system, we have decentralization in the sense of more participation in these rounds, and that leads to better outcome. Now, this graph basically plots the Herfindahl index, at the market level, and you can see, and this is in log scale, and you can see that the control system is sort of, above the treatment system has a lower HHI compared to the control system, meaning that it's more decentralized, and it's coming from the fact that more people are able to participate. And lastly, we have some, very suggestive evidence for scaling in the sense that the smart contract cost, after this sort of policy change increases over time, right? But of course, this is just sort of time series variation, and there could be many other confounders. So, just take it as a grain of salt. All right, so I'm already out of time. So let me conclude. Smart contracts could or have the potential to some degree disintermediate some trust enforcing agencies and reduce transaction cost. But achieving that full potential is going to depend on the scalability of the technology. Now, in this paper, we analyzed the effect of a scaling solution in the setting of a decentralized data feeds for smart contract. And the scaling solution is quite general. It's called off-chain solution, which is to move the data aggregation process, or in general, some computation process from on the blockchain to off the blockchain. And we find that the scaling solution leads to cost reduction and decentralization while the data integrity is not compromised. And that's coming from the fact that the lower cost allows for more participation in this decentralized voting, which actually increases the quality of data feed. Now, the contribution of the paper is that we provide some evidence about the trade-offs in keeping all the transactions on the blockchain versus using a so-called layer 2 off-chain scaling solution. And our results suggest that as technologies improve, so that scalability gets better, then the original promise of blockchain, of decentralized and scalable trust can be achieved. So that's all I have for the talk. Thank you very much for your attention and questions, and I'm happy to talk more. If you have more questions, I'm very happy to answer them. Thank you.
Okay, so thanks a lot, Xiang. It was a great, super interesting talk. So we have a few minutes left for Q&A. So whoever has a question, please write in the chat or just unmute yourself. Hannes?
So I think Alia, she was raising her hand.
Oh, sorry, yeah. So Aida, you can just unmute yourself if you want.
Oh, okay, thanks. Yeah, I'm still kind of wondering about Nancy's earlier question, which I thought was a good one about the nature of decentralization that is being achieved here, and particularly in view of things like or disasters like the Ronin hack that was on a side chain related to Chainlink. Can you talk a little bit more about the security implications and why do we have these huge hacks at the same time as you guys say that data integrity and security is improved?
Right. So I guess, so here's the thing. What I was trying to say is that, so I'm not saying that off-chain peer-to-peer network is better than doing things on-chain. In fact, that's probably the opposite is probably true. That doing everything on-chain is probably the safest way compared to any sort of off-chain or sort of side-chain solutions. I completely agree with that. What I guess the point that we're trying to make is that we need to essentially think about the trade-offs of sort of that increased security when we put everything on the blockchain versus the $260 million that we are saving when we do some of the things off the blockchain, right? So now in the data, we do not observe, or in the short time period of the data, we do not observe that security is sort of compromised, but that does not mean that over the long run, this is absolutely going to be the case. It just means that it's a small event. Even though it's disaster, all the disasters are tail probability events. It's just something that we don't observe in the data. So it's really important to keep that in mind. And to inform optimal policy making, it's also to keep that in. It's important to keep that in mind while keep sort of the amount of dollar saving in mind to sort of inform policy making. So that's, I guess, the trade-off aspect is sort of what we are trying to talk about. Now, in terms of the P2P network, I think there's so I'm not a computer scientist. I know there's a large literature in computer science that talks about when P2P systems can fail. So all of the results are all there. So that would be the shortcoming in terms of the security of using P2P2 network over blockchain. So one thing that, from a very non-technical person's point of view, I think like one hazard is that, say, if I just sort of cut the internet of that committee or that P2P network, then that P2P network will not be able to, say, communicate with the blockchain, right? So obviously that won't happen if all the votings took place on the blockchain, right? So nobody will be able to cut your internet access, like for you not to be able to talk, right? So, I mean, that's just something on top of my mind, but I'm sure there are other sort of security challenges with P2P network relative to on-chain, on the blockchain.
Okay, I think that helps. Just a quick reaction that that's not the trade-off that you're highlighting with this research. And I think that's a central trade-off. The very small risk, but increased risk of a huge disaster is a big issue in this context. But anyway, thanks for the explanation.
Thanks.
Hannes,
Yes.
Arthur, go ahead. I think you were before me. Yeah.
Thank you. So very interesting presentation. I'm just curious. I mean, what you're trying to look at right here is not necessarily layer 2, as we call in blockchain. Usually it's like Polygon networks or Bitcoin Lightning Network. Is more like off-chain scaling solutions as you put in our slide. And that has been widely adopted now by many DAOs. Just to give you one example, Decentralization, the game, instead of having voting on chain, they use one technology called Snapshot to do all the voting. They still have all the signatures and everything from asymmetric encryption, but all these signatures happen off-chain, and they only have the result of the whole thing on-chain. So I'm just curious if you thought about applying the same kind of analysis to a different scenario, because
that would be super interesting.
Yeah, because if you think about Decentralization, they have a period of time when the whole thing was on-chain, they moved off-chain, and you can literally apply the same techniques and same ideas there to their data set, but now for the governance of DAOs.
Yeah, no, I completely agree. I think this off-chain solution is like completely general. The idea is to take some of the on-chain computation off-chain, and there are many companies that are doing that. So I completely agree with you. And I agree that when people in the industry talk about layer 2, they typically do not mean off-chain solution. So, we have to think about the terminology. So if I think about moving something off the blockchain, it's in some sense a layer 2, but I see. Yeah, it's not what industry people think about when they talk about layer 2. I agree.
Yeah, and if I can follow up with one more question, a very short one. There can be potential confounding factors as well in your analysis, right? So I believe a previous person mentioned hacks. The period of time you collect the data from, there have been quite some big, massive hacks going on that affected price, that affected participation on the chain. Have you considered these potential confounding factors as well in your analysis?
Right. So the thing, a nice feature about our identification is that we are actually looking at a within variation. So what I mean is that we're controlling for blockchain by data feed by time fixed effect. So that means that we're looking at the same blockchain, same exchange rate data feed on the same date. And we have two parallel systems. And that's like we're comparing the output from the two parallel systems. So the assumption there would be that, if there's a confounder, right, there's hacks that affects how people behave, that's going to equally affect both the treatment and control group at the same time. So that's our take on it. But that said, the interpretation or the magnitudes of our estimate is, of course, conditional on the big background, which is what you said about the hacks, and that's very relevant to keep in mind of.
Thank you.
Yeah, thanks.
Hannes, your turn finally.
Yeah, thanks. So I have a more of a high-level question. I'm not sure if I'm thinking about it correctly, but so when you talk about decentralization, so what I was thinking is that there's still an actor that's Chainlink, that's I don't know, that's in some way doing something in a centralized way, right? I mean, granting access to whatever they're doing. So
I completely agree. So my take or my understanding of this is that decentralization is sort of also a spectrum, right? You can have fully decentralized or fully centralized. Now, Chainlink it depends on what your benchmark is. If you're talking about Amazon, then Chainlink is sort of more decentralized in the sense that even though Chainlink makes all these decisions, but at the end, all of these aggregation algorithms, all the decision rules that it makes is sort of on the blockchain. It's sort of a code that's written on the blockchain, so that people in the community can actually see them, right? So while they don't have direct control over them, but at least it's transparent. So in some sense, the people do have some monitoring power, which gives them a bit of power to sort of nudge Chainlink to make all these changes, right? So I would think that compared to a more sort of traditional closed platform like Amazon, Chainlink would still be more decentralized. Now, of course, we're like far away from sort of the ideal world, if you will, that everything is fully decentralized. But I think Chainlink is first of all, I'm not working for Chainlink now, so I don't have to say nice things about them. They actually, yeah. So they are I know they are moving sort of towards that direction in the sense that what they do, like their selection algorithm of choosing service providers and stuff, they're all codifiable. So ideally, it could be sort of a piece of code that's written on the blockchain that's decentralized. So people in the community, can vote on sort of what the code should be, and people can make changes. And Chainlink is sort of still incentivized to do this at the stage because of the fact that their foundation actually holds a lot of tokens out of the native tokens on the Chainlink system, right? So in order to use Chainlink, you have to use that tokens. So they're betting on the value of these tokens to go up, and then that's essentially how they are going to profit. When they're moving from like ideally a more decentralized or even a fully decentralized setting. So that's where their incentive comes from, which I think is also like what your question is about.
Yeah, I guess so I'm wondering a bit if there's an offer of off-chain scaling solutions, if there will be a tendency to centralization into one solution offered by one, I don't know, one entity like Chainlink that is designing the technology and that has to be used. If this is if you want a risk, if you're worried about,
Right.
centralization, but maybe this is actually getting off topic then.
No, I think it's highly relevant. I think eventually Chainlink is trying to make itself a DAO, like a decentralized autonomous organization, so that no one at Chainlink Lab has control over the entire system. But that's not the case, obviously, at this stage. Yeah.
Great. Thanks a lot.